Yeah, so at the moment, we are at the vehicles. Our engineers are on console, monitors underway. We are looking better on the weather this range, and we are targeted the very beginning of our window at 6:30 p.m. Central Time. Our objectives for today, really with the ship, are going to look very similar to the last couple of launches, looking to deploy those Starlink simulator satellites, fly a whole bunch of experiments during Starship's reentry, testing the limits of its heat shield and its flaps. Ultimately, we want to see ship do controlled descent, soft splashdown in the Indian Ocean. That's really what we're looking for today. Regardless of the outcome, though, goal is always to collect as much data as possible. That gets us one step closer to a fully operational Starship.
That's right. And either way, flight tests guarantee the maximum level of excitement. And Starship will allow us to fly the heaviest payloads ever flown and ultimately fly humans further into space than ever before, even all the way to Mars, as we always talk about. Our progress here at SpaceX is measured by getting closer to establishing a self-sustaining civilization on Mars, and these are the flights that are forging that path.
That's right. Now, a whole bunch has happened to get us to this 10th flight test. We're not going to go all the way back to the beginning, but we're going to start with Starship's 9th flight test, which lifted off in May. That one did end with what we call a rapid unscheduled disassembly, or a RUD, on both the ship and booster. Let's take a quick trip back.
So Flight 9 marked the first reflight of a super heavy booster. We saw successful hot staging and the first ever deterministic flip, which gives us extra performance. The reused booster was flown at a much higher angle of attack to push the envelope on capabilities. This did end up causing some internal structural failure, eventually leading to a rapid unscheduled disassembly at landing burn.
Ship, though, continued its ascent. While it was going, though, we saw pressure dropping in the main fuel tank, rising in the nose cone. In this view, you can see pop. The fuel diffuser inside the pressurization system, we had a hole develop. The ship still managed to complete its ascent burn, got to its planned velocity, got to second stage engine cutoff. Really huge moment.
After that, though, we did run into some issues with attitude control, which eventually led us to skipping the payload deploy and Raptor relight demos. Starship eventually re-entered the atmosphere in an off-nominal attitude, and communication was unfortunately lost approximately 46 minutes into the flight test during entry, but not before we got one heck of a light show.
That's right. Looking forward to another one today. The booster RUD, we went back and looked at it. That was caused we had a much higher than predicted forces on the booster structure, really honing in on that internal fuel transfer tube inside. That was all due to that angle of attack experiment we were running for today's flight, and any of the remaining ones on this version of the booster. We're just lowering the angle of attack for the booster as it comes in, relaxes those forces, minimizes the likelihood that we see that kind of structural failure.
Yeah, and then over on the ship side, we redesigned the part of the fuel pressurization system that failed on Flight 9. We put it through a more rigorous test campaign and subjected it to flight-like stresses, and eventually we were able to actually run it for more than 10 times the expected service life with no damage, which was super exciting. Yeah. Our goal is always, of course, to make it through all of the objectives we set, but any result that teaches us more about Starship performing in the real-world environment helps us to make those targeted iterations and improve quickly.
Yeah, that's kind of been the secret to our success. That's how we developed Falcon 1, our first rocket. That's how we developed Falcon 9, which we've already flown more than 100 times just this year. A little insane, and 500 flights overall.
Yeah, super exciting for Falcon 9. And again, we're trying to follow their lead and launch, learn, and repeat.
Yeah, so we finished Flight 9. We were getting ready for Flight 10, and if you followed along, we originally had a different ship number 36, that was slated to fly on Flight 10, but that experienced a pretty major anomaly during its static fire test out at our Massey's test site. We were actually in its second static fire, a 6 engine. We were loading cryogenic propellant on board. We saw a sudden energetic event, complete loss of Starship, damage to the stand, and some of the immediate area surrounding it.
The most likely root cause that we were able to identify was undetectable or under-screen damage to a composite overwrapped pressure vessel, or COPV, in Starship's payload base section. To address this probable cause, we are operating the COPVs on Starship at a lower pressure and also implemented additional proofs and inspection methods.
Meanwhile, though, got to maintain our launch schedule, got to keep testing, so we pivoted to actually using the launch pad, the same one we're stacked on right now, to do ship static fire tests, something we had never done before. A retrofit was the fastest path to get back to flying. The team was able to engineer, implement a solution. We used a ship transport ring sawed some stuff off, welded some stuff on. We're able to mount the ship, load propellant using what we usually use for the booster, and then do 2 different static fires on that orbital launch mount, doing that in a matter of weeks.
Yeah, it was really an incredible turnaround to see. And the static fires did give us the data we needed to progress to launch and are a prime example of our engineer and technician teams working together to build creative solutions to keep us charging forward to bring Starship online.
Yeah, even while we did all of that, we're still in the process of rebuilding that Massey's test site. That's where we want to continue testing our ships in the future, and we're getting it ready for that next generation of Starship version 3.
Yeah, very excited. I'm looking forward to it.
Yeah.
Okay, back to the rocket on the pad currently. Starship is the first orbital launch vehicle engineered to be fully reusable. It's built for frequent flights and a significant amount of payload.
It is the largest rocket ever made, ever flown, largest flying object in human history. It's going to be the vehicle that enables our foundational mission to eventually bring humans to Mars. I recently, just yesterday, got a chance to do a deep dive into kind of everything big picture Starship. Had some special guests, Elon Musk and Bill Riley. Let's take a look back. We're about to launch the largest flying object ever made, but this isn't on the radar for everybody, and we know that. So we want to kind of take a beat, pull back, do a little bit of Starship 101. To do that, I've got some special guests crashing the webcast today. Joining me now in Star Factory, Elon Musk, Chief Engineer at SpaceX, Bill Riley, our VP of Starship Engineering. Thanks for being here, guys. I know we got a rocket about to get off the pad, but let's start people off like high level. Like, why are we here? What the hell are we doing here?
Well, I don't know about everybody, but I'm here to try to build into the future that I imagined and dreamed of as a child, where starships with people are out among the stars exploring the universe.
Yeah, so the why, it's always important to explain the why of things. And the why of Starship is that we want to be a multi-planet species to extend consciousness beyond Earth, I think for 2 main reasons. One is to ensure the long-term survival and prosperity of life as we know it in consciousness, which if we are a multi-planet species and ultimately a multi-stellar species out there among the stars, the probability of survival is much, much longer. That's kind of the, defensive aspect or life insurance for life collectively. But then there also need to be things that are inspiring and exciting and that give you reason to live. Life cannot just be about solving one tragic problem after another. There must be also reasons to get up in the morning and be excited about the future. And a future where we are a spacefaring civilization is infinitely more exciting than one where we are not.
And we're doing it all pretty unique location. I mean, the pad's behind us. We got rocket on the tower. We got another tower with it. We're sitting inside Star Factory. And I mean, it wasn't like this for very long. This is all pretty brand new.
Yeah, I think we moved Starship here in about the early part of 2019, so we've been coming that entire time and seeing the site evolve from a double-wide trailer and a tent where we built Starhopper to the first suborbital test flights, and now we have behind us 2 towers for the first time as we build towards the first operational flight from the second tower at the end of this year, and this beautiful building, million square feet, where we're able to work towards a production line of Starships.
Yeah, the SpaceX team has done an incredible job of building out really the most advanced rocket manufacturing facility that has ever existed. This is far beyond any rocket fabrication facility that has ever been built. This is essentially alien-level technology, and it was all built here basically down by the Rio Grande River and close to the beach. It's an incredibly improbable location, and this used to be a sandbar. I think we're about, 3 feet or about a meter above sea level. It really was nothing. If you see the time lapse from sandbar to two launch towers and a gigantic rocket factory with high bays, and we're going to be building something called the Gigabay, which is like one of the largest enclosed volumes on Earth. So it's sort of like a gigantic Borg cube that we're going to be building here for building and storing these gigantic rockets. It's really spectacular, and anyone can come and visit. So because we're on a public highway, and we're literally by a public beach, you can actually come and see the rocket. You quite close up. I mean, you can drive past it, and you can also look at the factory. And anyone can do this from anywhere in the world. So if you can come and visit and check it out. So I think it's pretty cool that it's
just not right now.
Just not right now.
Just not right now.
Obviously not when we're launching because there's some safety issues, but the rocket's often just sitting on the pad without any propellant in it, and then you can just come here and visit. It's very easy.
Yeah, I think it's a really special place. Yesterday, the ship went down the road behind us, and I saw families outside going for on Sunday going for their Sunday stroll, and they were greeted by Starship going down. And I think that from the very beginning, the thing about Starship, different than Falcon and other rockets that I'm aware of, is we designed it to be mass-produced and mass-produced at scale. And it's not about building one Starship and getting to orbit once. It's about doing it in a sustained and rapid way.
Yeah, we're aiming for ultimately thousands of ships to be built per year, which is what's needed in order to construct a city on Mars that is self-sustaining. And the major fork in the road of destiny will be when the Mars city is capable of surviving, even if the resupply ships from Earth stop coming for any reason. And that reason could be something cataclysmic, or it could be that that civilization simply subsided. There's always this debate throughout history of will civilization end with a bang or a whimper. But either way, if the critical thing is to get to the point where Mars is self-sustaining and can survive even if the resupply ships stop coming for any reason, which means that you need to build an entire base of industry on Mars in order for Mars to survive. For example, it's not simply enough to build a chip, like a computer chip factory, but you need the ability to build computer chip factories. So this is going to really take a lot of tonnage. I mean, my guess is at least 1 million tons to the surface of Mars, and maybe it takes less than that, but it's going to be a lot. But this is a very exciting future. It's one which will ensure the long-term survival and prosperity of life and consciousness, and it's the critical stepping stone to get from this solar system to other star systems, and perhaps go out there and explore, and perhaps we'll encounter alien civilizations that maybe they're alive now, or maybe they enjoyed a period of prosperity for millions of years, but also died out millions of years ago. So it's humbling to think of the age of the universe, according to the standard model of physics, being approximately 13.8 billion years old. So an incremental million years would be 3 digits past the decimal point. And if you look at, say, our civilization and measure our civilization by the first evidence of writing, which is about 5,500 years ago, civilization as measured from the first writing is only 1/1,000,000th of Earth's existence.
Or blip.
Yeah.
Yeah.
Flash in the pan so far.
Yeah. Well, we're getting some cool shots. Rocket out on the pad right now. We tell people, like, come down, see it. It's hard to get, like, a sense of scale of just how massive this thing is. And we were able to catch somebody working on it a little while ago. And, like, part of the reason you said we're sending millions of tons, that's kind of why this thing is so massive. I think in this image, Dan,
you can actually see the person working at the bottom of the ship, and as we zoom out, you see the full ship, that sort of two-tone silver and black, and then the booster below it, right? And it really sets the scale, which doesn't come across, I think, other than in person. And when I do tours, I like to say Starship is real, Starship is big, and Starship is really big. Mm-hmm. And I think you can see there, and with the factory shots you saw earlier, again, we've got Flight 10 on the pad, but we got many more behind it.
Yeah, so I posted a video yesterday of just a brief scan of part of the Starship factory, and you can get a sense of the scale of the factory. Yeah, I guess we could talk a bit about why Starship is the way it is. Like, for example, why is half of the ship black and half of it is silver colored? And that's because the bottom half of the ship, the bottom as seen from orbital entry, has a heat shield on it. So the black there is the heat shield, and then the core structure of the rocket is a special alloy of stainless steel, and that's where you see the sort of shiny silver parts are stainless steel. The reason for steel over aluminum is that the heat of atmospheric entry and the heat of the rocket engines is enough to easily melt aluminum, but steel is much more resilient against both ascent heating, but especially the reentry heating. And you don't have to paint it, which is actually very difficult to paint a large object that is going through cryogenic cycles and have the paint stay on. It's quite challenging.
And so we've talked about it. It's massive. It obviously takes a whole lot of energy to make that thing move. And that's where Raptor really starts to come in, most advanced engine on the planet. Giant
yes.
lightsaber.
No, that's a lightsaber and a half. You would get vaporized in an instant if you were standing in front of Raptor. So, yeah, burnt to a crisp less than a second. So in order to create a fully reusable orbital rocket, you have to advance the state of the art in every part of the rocket. That means the engines have to be better than any engine ever. The structure's got to be better than any structure ever. You've got to have a means of bringing the rocket back to the launch pad. You've got to have a fully reusable orbital heat shield, and that no one has ever made a fully reusable orbital heat shield. The space shuttle, for example, required 9 months of refurbishment between flights. So the space shuttle heat shield would come back essentially partially broken and would require many months of refurbishment in order to fly again. What we're trying to achieve here with Starship is to have a heat shield that can be flown immediately. So the ship, both the ship and the booster, would be caught by the tower arms, and the booster would be placed immediately back on the launch stand, and the ship's got to orbit Earth at least once, but then could be back potentially in one orbit, but in most cases several orbits. So the ship would come back several hours later, but then be caught by the arms and placed on top of the booster. You could also have multiple ships ready so that a single booster could service 5 or more ships, so that you could be flying the booster in theory, every hour. This is kind of a profoundly fast speed, obviously, for the largest flying object by far ever made. But it's the reason why we catch the booster with the tower arms, and the ship also will be caught with the tower arms, because that's the fastest way to get the booster and the ship back to flight. If we had instead put landing legs, which we have done before for the ship tests, we actually had landing legs that flipped down, and the ship we've successfully demonstrated landing with legs. But if you do that, if we were to do that with the booster and the ship, here we'd have to land somewhere else with the legs, then lift the rocket, stow the legs, transport the rocket back to the pad, which is very unwieldy when you've got a gigantic thing. Then it would be picked up by these tower arms and placed in the launch mount. That would delay the reusability dramatically and would add a lot of mass with the landing legs. So that's why we catch the rocket with the tower arms, because it's the same tower arms that put the rocket in the launch mount are used to catch the rocket. And that means that we can put the booster back in the launch mount in less than an hour after liftoff. In fact, the booster is going to come back very fast. Like, 5 or 6 minutes later, this booster is coming back one way or another, or not coming back. So then you really have propellant fill time, which can be brought down to about 30, 40 minutes. And that means it is theoretically possible to fly the booster again in less than an hour.
I think when I think about it, it's the jet drives up to the jetway, the people get off, new people get on, and it leaves. You don't want to land the jet on a different airfield and then tow it over to the jetway. So it's just operationally simpler and faster.
Yeah, we've had a lot of success with the booster, 3 for 3 on the catch attempts. When we bring it back, we've reflown one, so awesome. And then again, Starship superpowers, the whole thing is reusable. So ship reusability is like what we're working on right now. We've been able to get some really spectacular reentries on a couple of flights, hoping to get this one for reentry on the V2 ship. But yeah, that fully reusable heat shield, that thing that has just never been done before, that's one of the things we're really looking for that data on.
Yeah, I mean, there are thousands of engineering challenges that remain for both the ship and the booster, but the single, maybe the single biggest one is the reusable orbital heat shield. We are confident in making a fully reusable orbital heat shield, but it will require many flights, many iterations to figure out where the weak points are in the heat shield, where we need to change the design, either strengthening the tile or changing how big the gap is between tiles, changing what's underneath the tile. There's a 100 different variables that we could tweak with the ship tiles, the heat shield tiles. But the only way to know exactly what we should be adjusting is to fly repeatedly and be able to examine the ship upon landing. And we have successfully brought the ship back through the atmosphere and achieved a soft landing multiple times. So we know that this is possible, but we have in the process shed many heat shield tiles. So we need to be able to do this without shedding heat shield tiles and do so repeatedly.
And I think what you're seeing now is the Starship. This is CG of it coming in and landing on the tower, much like the booster, but there's some additional challenges there where we need to make sure we don't scrape the tiles off as we slide along the chopstick
We can't
arm.
shuck the heat shield.
Don't crush the ship.
Rapid reusability.
If we shuck the tiles, then that's obviously going to fail the reusability test.
So ships can use the tower to land and catch, like the booster here on Earth where towers are available. And for our initial landings on Mars and other planets, we'll need landing legs that deploy much like what you're seeing here with Ship 15 when we did our suborbital test to prove out the precision descent landing, which was a successful test. We actually landed to, one was we were able to actually recover it, and you can see it here in the rocket garden if you visit Starbase.
Yeah, so the rocket garden that Bill mentioned, we have actually a whole bunch of boosters and ships, and we'll be adding to them over time. So you can see an evolution of Starship just by driving down the highway.
Yeah, so reusability is key. There's some other technologies we're still looking to prove out. Really big one is going to be the on-orbit refilling. Looking to do that next year, and that's really what's going to kind of unlock, Starship going everywhere else, going everywhere beyond Earth. And that's something that's, again, never been done before, kind of like that reusable orbital heat shield, but it's going to be something that's kind of some of the other secret sauce to Starship, where we're going to be able to send hundreds of tons per ship to Mars.
Yeah, I like to think of it as if we get to orbit with a full cargo bay, but we're empty on fuel and oxygen. So basically, we're running on fumes. Then we send other ships to dock, transfer propellant, and now we made our two-stage rocket look like a many multi-stage rocket. And we get all of that performance, and we can take that full cargo bay now wherever we want to go.
Yeah, so a crucial technology that we hope to demonstrate next year is this orbital refilling, much like aerial refueling. It's essential for being able to send significant payload to Mars. So you essentially send a ship to orbit with a few hundred tons of payload, sort of a filled payload bay. But once it gets to orbit, the tanks will be mostly empty. And then you send up additional tanker ships to refill the Mars ship's tanks so that it can thrust from Earth orbit to Mars and have enough propellant left for landing. So this is orbital refilling is also not something that's ever been demonstrated before. So that would be a brand new technology. We obviously have at SpaceX figured out how to dock repeatedly with the space station. So in a lot of ways, this is like docking, and in some ways it's easier in that SpaceX is docking with its own craft, but no one has ever demonstrated propellant transfer in orbit, to the best of our knowledge, and so this would be propellant transfer at a very large scale. And but with full reusability and propellant transfer, those are the key technologies needed for building a city on Mars. And I'm confident that the SpaceX team, which is incredibly talented, will achieve these goals. And we will be landing ships on Mars in the future and building life on Mars, building greenhouses and life on Mars, and ensuring the long-term survival of life as we know it. And it's important to note here that obviously, we are effectively stewards of life here on Earth. That the other creatures cannot build spacecraft and get to other planets. So if there were to be a cataclysmic event, like a giant meteor that destroyed the dinosaurs, or ultimately the sun will expand to envelop Earth and destroy all life, we know this is an undisputed fact. Then if we don't take life to another planet, life will be destroyed. So it's incumbent upon us to ensure that we do bring life to other planets and ensure the long-term survival of life as we know it on planet Earth.
And I mean, aside from that, there's so much that Starship unlocks by being able to do these things. Like, we'll be able to go to Mars, but there are other just transformational things by being able to take that many people, that much stuff to space for that much less money.
Yeah, I mean, I think like understanding our planet better, being able to move people around the planet, make it feel smaller and more accessible. You could go anywhere on the Earth, in less than 40 minutes, basically, in terms of flight time. So I really do see Starship as being this thing that can connect us, just like Starlink connects our information. This can connect us more physically.
Yeah. So there's really nothing faster than a rocket. Really, an orbital rocket is the fastest thing that we know of of the fastest means of transport. So, like, you could go from LA to Sydney in less than half an hour. You could go LA to Tokyo in less than half an hour. You could go from New York to Singapore in half an hour. Everything's probably half an hour, basically. Some things might be 10 minutes.
Yeah, that's true.
I mean, yeah, sign me up for that, please. All right, cool.
Across the Atlantic in 10 minutes, no problem.
Please, yes, sign me up.
You're going 25 times the speed of sound, so that's 30 times faster than a commercial aircraft.
And it's a whole hell of a lot better view.
Yeah, it's a hell of a view.
Yeah. All right, cool. Anything else, guys? Anything else?
Well,
you're really excited about
we could
coming
say
out?
a lot more.
Yeah.
Maybe we should go check in on the rocket and get on console.
We're going to go back on console to hopefully the weather supports a launch tonight. Yeah, thanks for tuning in, and thanks for your support.
All right. Obviously, that was really cool. There's probably not anybody else cooler on the planet to talk Starship with. Still very ready to sign up for that point-to-point travel too. Also, though, it's really hard to relay just how much power is being generated by these engines on this rocket. We try to compare it to something like a little bit closer to home for people. We've used an airplane a lot of times. That's just something a little more tangible to folks.
Yeah, if you were to stack Starship up against one of the biggest airplanes out there today, the 747, just one Raptor engine is double the thrust of all 4 airplane engines. Super crazy to think about. And the Super Heavy on the pad right now, which has 33 Raptor engines, is putting out as much power as about 64 747s.
Yeah, it's, again, just a tremendous amount of power. World's largest flying object. It's crazy. And again, that was really cool to just go through that. I love to geek out as much as everybody else over all the nitty gritty, but always important to remember there's a lot of people that just don't know that all of this is happening. So it's cool to remind them, cool for everybody else out there to help us spread that word. All right. So right now we are 17 minutes, 12 seconds and counting until the 10th Starship flight test. While we do have a moment, though, let's check in over with Tyler Lionquist over in Hawthorne for the latest on Starlink. How's it going, Tyler?
Thanks, Dan and Amanda. I'm Tyler Lionquist, and I'm a Starlink business analyst here at SpaceX. Starlink is SpaceX's low Earth orbit, high-speed internet that's bringing connectivity both on Earth and in space. Now, for today's mission, Starship is outfitted with 4 Starlink terminals, allowing us to get live views of ship while in orbit and all the way down to splashdown in the Indian Ocean. Our Starlink satellites are built in Redmond, Washington, which is also where we monitor the health of the entire constellation. So let's take a quick look for more on Redmond.
What a lot of people might not realize when they think about the scale that we're operating is that actually 2/3 of the operational satellites in orbit are Starlink satellites. And then all of those Starlink satellites came from right here in Redmond. We've currently got a constellation of over 8,000 satellites that are flying around in orbit. So they're working together to fill out the whole surface of the Earth, make sure everywhere can have service. So we have these laser links that are connected between the satellites, so each satellite can pass data from one to the other. That is what allows us to have these hundreds of gigabit links between satellites, and that's what allows us to connect every corner of the Earth to high quality, high speed, low latency internet. When you think about that Starlink that you have at home, the technology that's in there and that's in your antenna is very similar to the antenna that's on the satellite. We use what are called phased array antennas, which is a fancy way of describing an antenna that's made up of many little antennas that work together in order to direct their energy to a specific spot on the ground without a motor.
Generally, satellite manufacturing is a very slow process. It takes people weeks or months to build a satellite. At SpaceX, we iterate very fast, and we have learned how to build satellites at the 70 sats a week rate. As we have focused a lot on production rate, we have not forgotten about our satellite reliability, which is critical to our mission.
If you look at the whole world and you ask, where is the satellite industry? It's right here in the USA, in Redmond, where the vast majority of satellites being built are being built right here. Starlink is a truly game-changing technology, and it's all supported by the global satellite constellation from this space here in Redmond. And we're really just getting started at the very beginning of what we want to do with Starlink.
Now, as we mentioned earlier in the show, one of today's objectives is for SHIP to deploy Starlink simulator satellites that represent the advanced V3 satellites Starship will be launching in the future. And as you can see here, once Starship reaches a nominal orbit, the payload door will slowly begin to open to prepare for deployment. The Starlink satellites will be dispatched relatively quickly, one at a time, like a Pez dispenser, as you can see on your screen. They'll be situated in one long stack, taking up as little space as possible, allowing for an efficient deployment sequence. Once a set of Starlinks are deployed, the next set advances and deploys until they are all drifting away from Starship to prepare for their on-orbit life. Each Starlink V3 launch on Starship is planned to add 60 terabits per second of capacity to the Starlink network. That's more than 20 times the capacity added with every V2 mini launch on Falcon 9. So we're talking about a massive increase in performance all around, which will ultimately enable Starlink to serve as the communications backbone of the missions to the Moon and to Mars. So for now, we're going to turn it back over to the team at Starbase.
Thank you so much, Tyler. Okay, let's turn our attention to today's flight profile, which will feel familiar because it is. We're looking to get our first re-entry with this iteration of SHIP, and we're again intentionally stressing Super Heavy during its return. The next generation booster is on the horizon, so the objective is to push and learn all we can from this current version.
All right, let's jump right in. As always, it's going to start with liftoff. Super Heavy ignites 33 engines lifting off from Starbase in ascending. It's going to power that ascent for about 2.5 minutes until we get to hot stage separation. Super Heavy shuts down all but 3 engines, deeply throttles the remaining ones, stage 2 lights its, and flies away. We have stage separation, a directional flip. It's going to descend. We're going to do some landing burn experiments and then do a splashdown in the Gulf.
Meanwhile, SHIP continues on with its ascent burn, again reaching a planned suborbital trajectory. We'll attempt to deploy 8 Starlink simulator satellites and then head back for re-entry, where we'll be testing multiple experiments, including missing tiles, metallic tiles, and intentionally loading the vehicle's flaps. SHIP will also attempt a flip maneuver, and if all goes as planned today, we'll conclude the test with a softwater splashdown in the Indian Ocean. So that's what we have on deck for Flight 10, which is just about 11 minutes, 40 seconds from launching.
That's right, and so just a quick status check-in. So as you said, we're about 11.5 minutes away. We have some good news. We got our latest range and weather status, and surprise, everything is looking green today.
Thank
So
goodness.
that's the biggest news that we were looking for. Again, weather is the main watch item for today, but we are green right now. We're not tracking any issues with the vehicle or ground systems, so we are looking pretty good for launch. We did all of our normal pre-flight checkouts with all the different vehicle and pad systems. At this very moment, we're almost done, or we're pretty far into our prop load on ship and a little bit more to go on the booster.
Yep, looking closely, it looks like we're nearly closed out on ship, like Dan said, about 70% of the way through on both methane and LOX on the booster side. We'll continue loading prop for a while. We'll close out at about T minus 30 minutes, 20 seconds on ship, and then 30 seconds later, we'll finish up loading prop on the booster.
Yeah, so bottom line, a little over 10 minutes to go. Range is green, weather is green, vehicles looking healthy. We're looking good to launch right at the top of our window at 6:30 p.m. Central Time.
Can't wait. All right, now let's quickly talk about Mars, since everything we do is part of our foundational mission to get to the red planet. Each Starship launch is to learn more and more about what's needed to make life multiplanetary and to improve ship to the point where it's taking millions of people to Mars.
Yeah, we've shared the plan previously in the last couple of months. We're looking to start sending the very first Starships to Mars next year. These missions, not with people. We're just looking minimally viable landers, so let's just prove that we can get there. And so we're just going to focus on learning as much as possible, but looking at all of those different phases, you know, prop load, prop transfer on orbit, sending stuff out to Mars, doing the transit, doing the entry, and just doing a landing.
And in our next window, around 2028 to 2029, we're going to attempt to land the initial infrastructure and start delivering more equipment as well, while evaluating available resources on the red planet. And we will also have Optimus on board for the ride, who is designed to do the initial heavy lifting.
Well, looks like we're doing some flap checkouts real quick on the ship as we are coming up on 9 minutes. Back to Mars, though, as those wrap up by about 2030, 2031, we'll continue to increase the payload per ship, build out more infrastructure out there on Mars's surface, start to mine some of those resources, set up some propellant generation plants, build up some fuel and some oxidizer to send Starships back from Mars. By the time we get all the way to 2033, we're looking to double the amount of payload we're sending with each ship as we get closer and closer to building a self-sustaining presence on the red planet.
Yeah, definitely lots of exciting missions ahead of us, and these are going to be crucial to setting up what we'll need for humans to eventually inhabit the planet, and we won't be doing this alone. The Italian Space Agency and SpaceX recently signed a first-of-its-kind agreement to carry Italian experiments on the first Starship missions to deliver customer payloads to Mars. So these payloads will include a plant growth experiment, a weather monitoring station, and also a radiation sensor to gather scientific data during Starship's approximately 6-month interplanetary coast phase from Earth to Mars, and also on the Martian surface.
It's a really exciting mission, makes showing up for work really fun for us. We're going to need to launch a whole lot more, though. So while we're just under 8 minutes away from launch today, let's head back over to Tyler and Hawthorne, talk a little bit about how we're going to be increasing the number of Starship launches going forward. Tyler?
Thank you, Dan and Amanda. So to put it plainly, in order to launch more Starships, we need to build more launch pads. And that's exactly what we're doing at Space Launch Complex 37 at Cape Canaveral Space Force Station in Florida. Now, Pad 37 has a storied history, most recently with the Delta IV rocket and for the missions for the U.S. government. And prior to that, the pad supported critical development for the Apollo lunar program in the 1960s. And we are honored to have the opportunity to continue making spaceflight history at Pad 37 with Starship. But first, we need to optimize the pad. So earlier this year, we started dismantling some of the existing infrastructure to prep the site for Starship operations. This will include up to 76 launches a year, with up to 152 landings at that location for Super Heavy and for Starship. And to support this flight rate, we plan on building 2 launch pads. Each will have 1 tower that can support launch and landing, plus deflector systems, launch mounts, and water deluge systems. This will also include a propellant farm that will produce propellant on-site and serve both launch pads. So there is a lot of work in progress, but Pad 37 is only one part of our plan for Starship operations in Florida. A few miles away from Pad 37 at Kennedy Space Center, our 380-foot-tall vertical integration facility called Gigabay is under construction. Once complete next year, Giga Bay will be capable of housing multiple Starships simultaneously for rapid assembly and integration. And meanwhile, at Launch Complex 39A, we're building Starship's infrastructure to support up to 44 launches and up to 88 landings a year, independent of operations at Pad 37. So with 2 launch complexes in Florida, we'll have the ability to fly up to 120 Starships annually, not including our flights from Starbase. So action is well underway in Florida. How's it looking in Texas?
Thanks, Tyler. Things are continuing to look good for launch here in Texas, so getting pretty close here with just under 6 minutes left. You mentioned Giga Bay. We're currently laying the foundation for Giga Bay here at Starbase as well, and we expect it to be up and running sometime next year. So yeah, there's a whole bunch of Starships on the way, and we're going to need more hands on deck. So come help us build the gateway to Mars. Visit spacex.com/careers to see all of our openings.
Yeah, I've been here for a couple of years now. Nowhere more magical, more inspirational on the planet. If you're a space nerd, you can come be like Amanda and build these things for real. It's pretty insane. It's super exciting. And yeah, come check us out. All right.
Absolutely. It's surreal to be here for sure. Okay, so we are looking like we're about 5 minutes away from launch and heading into terminal count. Range and weather are continuing to look good, and prop load continues on both stages of Starship. We'll close out here in just a minute or so.
Yeah, we're just about done. It looks like, let me grab my numbers real quick. We're not tracking any issues. We are just creeping up to 90% full on the LOX on the booster, a little over 93% on ship. Or sorry, fuel on the booster, and then ship we're just about to close out, so only a couple of minutes to go there. Once we're done, you've got just shy of 11 million pounds of liquid propellant on board those 2 different stages. We'll see a couple of final things happen. Well, you can't really see it. It's all going to be happening in our ground systems as we'll do pushbacks, clear all of the propellant out of those lines that are flowing up through the tower and into the vehicles, and get ready for launch. We just did our final guidance, navigation, and control system checkouts. Our flight safety system is being armed right now, and we're doing our final wiggle checks shortly with the engines on the thrust vector control. It's how we're steering the rocket. If we need to hold, which we are not currently tracking a reason to hold, that would come at T-minus 40 seconds. You saw us do that yesterday. We can hang out there for about 8 minutes or so right now. That's the point. It's built into the countdown. If we need to wait for clouds that just won't go the heck away or any other issues, we can hang out at T-minus 40 for a bit. But at the moment, we're not planning to do that.
Now, once we pass that T-minus 40-second mark, a number of events are going to occur in rapid succession. The ground spin and ignition systems come up to flight pressure. Ship will switch over to internal power, and after that, the QD arm lockout is removed in preparation for retraction, which occurs shortly after T0. And once we pass that T-minus 40 seconds, we do still have the ability to then recycle the count under certain conditions back to T-minus 40 seconds and hold there to assess what happened, and if we can proceed again back down to liftoff.
That's right. We do have at least one point of no return, though, if the water-cooled flame deflector underneath the launch mount fires off. That happens a little bit after T-minus 10 seconds. That doesn't turn off once it starts going, so we would have to stand down for the day if we do hit a hold or an abort at that point, so we can refill water tanks. At this point, we're not sure if we'd be able to attempt tomorrow because we have fully loaded the vehicle. We have to do a lot of fancy scheduling to get propellant in here as fast as possible, but again, we've got a pretty heroic and amazing team that works all of those logistics, got us into our attempt today after we did a unplanned wet dress yesterday during our attempt. So really exciting to see. But we're coming up on 2 minutes. We've got a green range. We are green for weather. Green has always been my favorite color, only more so now. And we are not tracking any issues with the vehicle today. So we are looking good. 2 minutes to go.
Yeah, again, not planning on holding at T-minus 40 seconds right now, but in case we do pass that and any issues come up, we can recycle the count. We're pretty lucky that we have this ability. Falcon doesn't have that built in, but being a developmental program, this affords us a lot more flexibility, so super useful to be able to have that. But again, not currently tracking any issues, so hopefully we'll be good to launch today.
All right, coming up on 90 seconds. We've got a pretty good crowd gathering with us right outside Star Factory here at Starbase. Looks like we're getting a quick TVC, that wiggle check.
This is my favorite view of the rocket.
Right under the launch mount. All right, so we've got crowds gathered out at Hawthorne, crowds gathered here at Starbase.
Super fun to see people getting to watch out on the front lawn now.
1 minute to go to launch. All right, so again, our hold point comes up at T-minus 40, not tracking any reason to stop there, so we should see us go right through that. All right, we are through T-minus 40. We are counting down. We're gonna let our flight director, Maciek Batura, take us the rest of the way. 30 seconds, the 10th liftoff of Starship.
T-minus 15. T-minus 10. 9. 8. 7. 6. 5. 4. 3. 2. 1. We have liftoff.
Vehicle pitching downrange.
Booster chamber pressure nominal.
All right, we're a little over 40 seconds into flight. 33 out of 33 Raptor
avionics
engines.
power and telemetry nominal.
Getting good call outs, healthy systems on the booster as it starts to pitch over the Gulf. All right, we're a little over 1 minute into flight, about to pass through max Q.
Max Q.
All right, so we are through the period of maximum dynamic pressure, max stress on the vehicle as it continues to fly.
Our next major event is going to be hot staging, which is happening in just over 90 seconds from now. To get ready, the booster will shut down all but 3 of its Raptor engines. The clamps holding the 2 stages together will release, and the Starship second stage ignites its engines. The ship then separates from the Super Heavy booster and heads to space. At the same time, the 3 engines still firing on Super Heavy will flip the booster around. 10 more engines will ignite for the boost back burn, putting the first stage on the path for splashdown in the Gulf. As we mentioned earlier, the hot stage will be jettisoned for this flight, and that should occur just after the boost back burn. So we're about to shut down the first stage and perform hot staging. So let's just watch and listen.
All right, seeing the engine start to throttle down.
MECO. Ship ignition. Boost back burn startup.
Stage separation.
Stage separation confirmed. We've got 6 engines running on ship. Booster is doing its boost back burn, continuing now towards its splashdown site in the Gulf. We are seeing all 6 Raptors lit up on ship. You heard them report ship chamber pressures nominal, so that chamber pressure, just that expected thrust level in those Raptor engines on the ship. 3 vacuum optimized,
Ship
3 sea
avionics,
level,
power and
all
telemetry
looking
nominal.
good. There's a view into the business end from the ship.
Spec burn shutdown.
All right, so at this point, we finished our boost back burn, so that was shut down. So that's the first of the 2 burns after a launch that the booster is going to do today. So now it's headed towards the Gulf. It's not going to be quite as an aggressive of a flight down. We relaxed that angle of attack a little bit, but we are then going to be looking for it to do its engine tests for the landing burn, and those are going to be a little unique this time.
Yeah, typically we start with all 13 inner engines lit for that landing burn and bring that down to just the center 3. But one of our test objectives for today is to simulate what an engine out situation would look like. So we're going to be intentionally turning off one of those center 3 and instead lighting one of the engines from the middle 10 ring.
Yeah, we did see one of those engines in the middle ring shut down during the initial ascent. Oh, looks like we have hot stage jettison. You can see it floating away there to the left of the booster. Yeah, we did see one of those middle engines shut down during the ascent. Again, we are resilient to engine out on Super Heavy. That's why we're able to get through our ascent. Starship flying on the expected path. There's still a chance that engine could be back in the mix for the very start of the landing burn, so we'll see if we light up all 13. But we've even done a landing burn at the tower with an engine out, so very resilient. We'll see how it does on its way down to the Gulf, though. All right, so we got a couple of minutes. That landing burn start should be just about 40 seconds away. That's always rad. You can see the boost plume itself in the background as it was coming in. All right, about 20 seconds to landing burn.
Ship Raptor chamber pressure is nominal.
All right, here we go.
Landing burn startup.
Looks like we got 12 of those 13.
Down to 3, including one of the middle ring. Down to 2. Nice little hover. And landing burn shutdown. And into the Gulf, here we come. And the booster has splashed down.
Incredible flight for booster today.
Meanwhile, back in space, about 7 minutes into today's flight, ship continuing its ascent burn. This goes until just about 9 minutes into our flight. That ship engine cutoff is slated for 8 minutes and 57 seconds. We are going to see those 3 RVAC, the Raptor vacuum engines. Those are the bigger circles in that little indicator on the bottom right of your screen. Those will shut down first, and we continue burning for a couple seconds longer on those inner 3 before we hit SECO, or second engine cutoff.
Yeah, these views are looking great. Once again, thanks to Starlink for getting us these views. It's just incredible. And we just heard the sound from booster.
It's like we just got a late boom from the booster.
Yeah, we have ship engine cutoff coming up here just shortly. And as we mentioned, today's flight test is not an orbital flight, but rather one that demonstrates Starship's orbital capability.
Starship from terminal guidance.
All right, entering the final phase of this burn. Under 30 seconds to go. All right, shut down the vacuum engines.
Ship engine cutoff.
We shut down those center 3. Successful ship engine cutoff.
Seco, baby. There we go. That's what we want.
Nominal orbit insertion.
All right, we just heard the call out for nominal orbital insertion.
All right, so ship is in space. There we go. We're seeing the flaps starting to move into a stowed position. That's why it looks like your camera's moving.
Yeah, exciting to see Starship safely in space and super pumped to see all the team's hard work in action here today. And of course, as guaranteed, it's been an exciting day so far. We successfully lifted off right on time at 6:30 p.m. Central Time. Thankfully, our weather was looking good today. Yeah, and booster, we had our soft splashdown in the Gulf, so ship continues on.
Yeah, ship able to complete its ascent burn all the way in. You can see some of the shadows start to creep as it's going to be eventually flying into an orbital nighttime. So we'll see some daylight start to go away. But ship is in orbit, completed its burn. And I mean, that's just the beginning. Now we've got a whole bunch more to go. So we've got some exciting demonstrations
Ship
planned while
saved.
we're on orbit. That right there, we just saved the FTS, the flight termination system. That's that automatic flight safety system we have on the vehicle. So that is now turned off while ship starts its coast period. We are coming up. Our next milestone is going to be the deployment of those Starlink simulators. We've got some payload inside of Starship that we're hoping to deploy into space for the very first time. That deploy is supposed to start at about 18 minutes and 27 seconds into the flight, so just about 7 minutes from now. That deploy will take place over a couple of minutes. It'll go about 1 satellite a minute, so we'll be spread out over that. It might get a little dark, but we've got a couple of views that we can show you to see that deploy in action. After that, we're also looking to do a relight of a single Raptor engine while we are in space. We've done this once before. This is not necessary to deorbit as we are in a suborbital trajectory, but this is essentially a chance to test out what we need to be able to do a deorbit burn. So we'll be doing that a little bit later in the flight, about 37 minutes or so into the flight. And then we get into reentry. We're looking to get that light show and, more importantly, get that really critical data about the ship's heat shield.
Yeah, exactly. At about T+45 minutes, we'll be heading for reentry. Again, running those experiments with the tiles. We're going to be doing missing tiles, metallic tiles, and also intentionally loading those vehicles' flaps. Hopefully, we'll also see a splashdown in the Indian Ocean today.
Yeah, we were able to get to a reentry last time, but we didn't have full attitude control, so we weren't able to go in, heat shield first the way we're designed to. So we ended up losing contact with the ship before we could make it all the way through. So you still get data, but you're not really getting the data that we want to make sure we're kind of stress testing the vehicle. As Amanda just said, we removed a bunch of tiles, and we do this in some intentionally scary places on the vehicle because we're really looking, are there spots that were vulnerable to this? Before we ever start moving towards, putting ship into a full orbital mission to then do reentries a little bit later on. So really, really critical to get that data, really looking forward to a controlled reentry.
Yeah, for sure. As we always say, our main payload is data, but today we also have some actual payload on board, and those simulators that Starship will be deploying, we'll see coming up here in just a few minutes. These are dummy satellites that are about the same size as our V3 Starlinks. We have 8 in the Starship PEZ dispenser and expect to deploy at a rate of about 1 per minute, as Dan mentioned earlier. Starlink is critical in all of our flights on Starship to get our main payload, data, as we always say. And in fact, it's Starlink that's currently providing these views you see as Starship cruises a couple hundred kilometers above our home planet and provides real-time telemetry through every phase of flight.
Yeah, we took a peek inside of the Starship payload bay there for a second. So there's 8 of them there. They kind of look just big steel plates, essentially. They're roughly the same size as those V3 satellites. When we do get that view inside of the payload bay, the payload door will kind of be on your right, and we'll start to see them go out like a PEZ dispenser. Yeah, here's a look inside. So those right down there in the center, they're kind of 2 stacks of 4 on either side. And then the payload door is just to their right. And so we'll look to see that open, and then those satellites start to go. We vent the nose cone, so we essentially bring it down to vacuum before we open the door. That was one of the things we ran into on the last flight, as when we had that fuel diffuser fail, the pressure in the nose cone became basically too high for the actuator of the door to open. So that's why we weren't able to get the door open that time. We have not seen anything like that on this flight. Everything's looking good with our fuel tank and our fuel press system. So we are hopefully just a couple of minutes away from seeing that payload door open and getting to our first ever payload. It's not the first payload we've ever carried, but it's the first one we're going to try and shoot off into space. All right, so I think we're supposed to open the payload door in just about a minute and change. And you're seeing a little bit of residual gas. And we opened the door once. I want to say it was back on Flight 3 when we were able to make it up into space. And you'll kind of see a lot of that gas rushing out into the vacuum of space. It's the residual that's left over after we've already vented it down. So kind of a cool light show. And then we'll get ready to deploy those payloads out. And as we mentioned, so we have crossed over now at this point into an orbital nighttime. So views from the outside will get pretty dark, but we'll see what we can see. We do this by design. We've been launching these later in the day here in Texas to try and get daytime views when we splash down. So it's daytime over in the Indian Ocean, where we are currently headed.
Just a few seconds until we expect those payload doors to open.
All right, one more time. Open the pod bay doors, Hal. So we are currently in payload deploy prep. And the door is open. All right, so the payload door is open. We should see the first satellite start to deploy at about T plus 18 minutes and 27 seconds. So should be only about 30 seconds. So one step closer. Hal listened this time. He cooperated. He opened the payload door for us. There's a view kind of behind the PEZ. You're looking out into the vacuum of space.
About 15 seconds until payload deploy.
Ship has transitioned to payload deploy. There we go. Pew pew. Been waiting way too long to do that. There we go.
There goes another one. Super exciting moment, as you can hear the energy in both Hawthorne and Starbase. Everyone's super excited for finally getting to deploy some of those simulated satellites.
PEZ system moving down. Next row. There we go. As we said, we're going to do about one every minute or so. And this is just kind of a dress rehearsal for when we're going to be deploying the V3 satellites. And these are just a massive, massive increase to Starlink's capability. Each one of them has, it's 60 terabits per second of capacity that's going to get added to the network per launch. That's 20 times more than what we're adding with every single Falcon 9 launch today, which, you know, step increase in capability. There goes another one. All right, so as we said, we've got 8 total that we're going to go through today. It's about a minute for each one, but looking good on payload deploy. All right, so we're about halfway through. When we actually start launching the V3 Starlinks on Starship, we're going to be flying about 60 each time. So it'll be about an hour to get through a full stack. But again, it's just going to be a massive increase in the amount of bandwidth. It's going to enable, you know, gigabit upload download for people with Starlink, you know, anywhere on the planet. And for us, Starlink is just a tremendous part of just the Starship flight test program.
Yeah, absolutely. Always getting us that data. And yeah, the amazing views we have on the vehicle today.
Yeah, views brought to you by Starlink of us deploying Starlink simulators before we deploy actual Starlinks. How deep does it go? All right, another one firing out. is looking smooth today. All right, looks like we've got one left.
Almost there.
Yeah, there you go. One remaining, so 7 of the 8 have been deployed. One more to go. And then we will have completed our first ever payload deploy operation. Just a reminder, we're on a suborbital trajectory. These satellites on that exact same suborbital trajectory, they're going to burn up entirely and are on that same trajectory towards the Indian Ocean. So the last one has been deployed. Starlink simulator payload complete. Heck yeah, everybody.
Loving the energy from Starbase and Hawthorne.
There, yeah, now it's empty. Looking a little lonely, but
Successfully deployed all the simulator satellites.
really, really cool to see them all out there. Again, people that have followed know Starlink's really critical for the Starship program, in addition to, getting all those views back from the cameras on Starship, which this is an external view. As I said, it's dark outside right now. The lights are off, so it's going to be hard to make stuff out. But in a little while, the sun's going to start coming up as we get to re-entry, which is going to be really critical. We use Starlink for Starship data. Cameras also use it on the cameras that we use to bring you views of these launches and also, hopefully, of the re-entry and splashdown. We'll see what we get from the Indian Ocean today. And that's just kind of how it all comes together. Like, we're using Starlink on the planet, off the planet. With Starship, we actually get pretty insane. If you're in the space industry, bandwidth to space is usually pretty minimal. We get about 120 megabits per second. That's split between our high-definition video and real-time telemetry. We get that every phase of flight, including re-entry. So it's not just giving us views of re-entry, but we're getting all of that engineering data in real time through phases that it used to be impossible to get that in real time. So just really incredible.
Yeah, Starlink definitely affords us all this capability. And reminder, it's the world's largest satellite constellation operating in low Earth orbit to deliver high-speed, low-latency broadband internet. This provides internet access to people all around the world, many of whom had never had connectivity before. Today, Starlink serves more than 150 countries, territories, and other markets, with over 6 million active customers and counting. To meet the growing global demand for high-speed internet, SpaceX expanded its factory in Bastrop, Texas, and also introduced Starlink Mini, as well as an upgraded version of the Starlink standard kit.
All right, now with payload deploy complete, Starship is now going to close its payload bay door and continue to coast towards Earth, around Earth, towards the Indian Ocean. Sorry, I'm really excited today. We are in space, people. Still a lot of major events to come, though. We are looking to relight one of those Raptor engines at about 37 minutes, 33 seconds into the flight, followed by atmospheric entry, hell of a light show, and splashdown. So we're going to go on a quick break, take a quick coast, sit back, enjoy the views. A little bit dark now, but they'll get better soon. A couple of space jams. We'll be back in just a few minutes for that Raptor relight and then re-entry. See you soon. right, welcome back, everybody. If you're just joining us, Starship just successfully deployed its first ever payload. We got 8 of those Starlink simulators out, and now we are expecting the relight of a single Raptor engine. That should be coming up in just a little under a minute. We're going to be lighting just one of those Raptor sea levels in the middle there. This is not a deorbit burn. It's a demonstration of what we'll have to do for deorbit burns, but we've done this once before. This is something we're really going to have to do when we're doing orbital missions, so it's a pretty critical test. We are just a couple seconds away. Sorry, we're about 20 seconds away, psych. So we got a little bit more time. So we are going to see one of those Raptor engines light back up. We are through the deorbit demo gate, so we should be seeing it momentarily.
Relight demo startup. And shutdown.
All right, looks like we confirmed the relight of one of those center Raptor engines. Second time we've done that, super exciting. Huge congrats to the team on this milestone. Very exciting to see.
That was a cool light show. Yeah, I get to do a mini version here. So again, that's going to be really critical for when we're doing deorbit burns. Like as you're going through, which if you don't have one of these, my God, they're so much fun. But like you're able to actually like light. Oh, Dan, turn it on. Light that engine. Not set my co-host on fire. And that's what we'll eventually do to, break out of orbit, come back down to Earth. So really cool to see one of those engines light back up again in space. That was our last in-space thing.
Very exciting. We're going to be heading back for re-entry at about T plus 45 minutes. So we're going to take another quick break, and we will see you soon.
Starship is approaching entry interface.
All right, so we are back. We are about 45 minutes into the 10th flight test of Starship. And as you can see, the light show has started. Re-entry has begun. We are starting to re-enter the Earth's atmosphere. We're moving about 5 times the speed of sound, and we're about to start barreling through the Earth's atmosphere and head for a splashdown in the Indian Ocean. We don't plan to recover the spacecraft today, but if we do make it all the way down to the water, who knows? But the goal of this part of the flight is to learn as much as we can about the ship's heat shield. A fully reusable, rapidly reusable heat shield for a spacecraft has never been done before. It's one of kind of the hardest engineering challenges still out there for us. And so this is the time to really dig in and get that data.
Yeah, absolutely. And re-entry is a critical phase of flight, so we'll need information on how the ship's system ends up performing. And Starlink will also help us gather as much data as possible, which is really the main reason why we do these flight tests. Starlink provides us with one more path to collect data to help us rapidly iterate on Starship's design. And if the ship manages to make it all the way to re-entry, we'll collect valuable data on the spacecraft flying through the Earth's atmosphere at hypersonic speeds, or more than 5 times the speed of sound.
Yeah, throughout history, a lot of times this is when you go into just a complete data and insight blackout, where that plasma sheath builds up around the outside of the spacecraft that blocks all of your signals that are trying to fight through to talk to either satellites out in space or towers down on the ground. Starship's big size kind of gives us awake, but What really helps us punch through is the fact that we're using Starlink. We're operating at just a much higher frequency. That's not what we want to see. So we just saw some of the aft skirt just take a hit. So we've got some visible damage on the aft skirt. We're continue to re-enter though. And again, we are intentionally stressing the ship as we go through this. So it is not guaranteed to be a smooth ride down to the Indian Ocean. We've removed a bunch of tiles in kind of critical places across the vehicle. So seeing stuff like that is still valuable to us. We are trying to kind of push this vehicle to the limits to learn what its limits are as we design our next version of Starship. So 47 minutes, 45 seconds into the flight, excitement ticking up a little bit on reentry already, but the light show is continuing. This reentry is going to take about 20 minutes or so until our planned splashdown. We were trying to splash down about 1 hour and 6 minutes into the flight.
Yeah, and one day Starship is designed to land on Mars, where there are obviously no runways or other humans to help us out. So we are doing propulsive landing instead of more traditional means such as parachutes. And propulsive landing enables us to have more rapid reusability with these vehicles.
Yeah, the ship itself, it's a little over 50 meters tall. We've got those 6 engines on board, the 3 vacuum, the 3 sea level, and they're down in that aft skirt region, which
flaps have control.
All right, so at this point, the flaps have control. That means we're getting into a dense enough part of the atmosphere that the flaps can start controlling us. We're not only reliant on those kind of reaction control system thrusters.
We're going to continue hearing some callouts as the ship makes its way back to Earth. So when we hear entry max heating and entry max Q, that will mean the ship has made it through the maximum heating and aerodynamic loads it will experience as it returns. So if it makes it through those, we can say we're doing pretty well.
I will say I'm happy re-entry cleaned off this camera for us. It was a little dirty from the weather, so thank you, Plasma, for giving us this view as we start coming down. The hit we saw to the skirt, definitely interesting. I will note, when we started doing these missing tile tests, we were intentionally removing them only in the skirt, as that's, you know, that's not over your fuel tanks or anything else that's kind of structurally critical for keeping the entire vehicle together. That obviously exposes your engines, so that could do some things for our landing burn, but for now, we are obviously continuing with this reentry. We are committed. Indian Ocean, here we come. 50 minutes since launch. We're going to see those colors start to build up a little bit. We are at the point where we're in dense enough atmosphere that the flaps have control. So about 74 kilometers in altitude. And you were starting to see some sunlight, so we intentionally time these launches right now so we have daylight. The sun should actually come up over the horizon on Starship in about 3 minutes. So as we get a little bit further into this reentry, that inky black below you is going to start to look like clouds and hopefully a bright blue ocean as we make our way down onto the other side of the planet. We've got these cameras. These cameras are really cool. We added these several flights ago, looking directly at the flaps as not just the heat shield, but these flaps, how they're able to control the vehicle, withstand that reentry, the seal locations, so kind of where they connect to the ship itself are some of the most critical. We will do missing tiles on those where, again, we're trying to, we're kind of being mean to this Starship a little bit. We're really trying to put it through the paces and kind of poke on what some of its weak points are. I mean, we even have missing tiles over some of those fuel tank sections of the ship itself. And so we're really trying to see what are our limits. We're doing this over a completely empty area over the Earth. Look at our Raptors there. We are assuming we make it all the way down to the ocean in one piece, we will attempt a flip and a landing burn. We do have at least one buoy, everybody's favorite camera person, out in the Indian Ocean right now, being powered by Starlink. So that's at our planned landing location. So if we're able to get any live views of the ship, that'll essentially tell you that we nailed our target. Able to do that on our 6th flight test, do it in the daytime, which was really exciting. All right, so we're about 10 minutes until we're probably going to start hearing some of the other big milestones coming up.
Yep, in about 10 minutes, like Dan said, Starship will be transonic. This is going to be the period of flight where the velocities of airflow surrounding and flowing past the vehicle are concurrently below, at, and above the speed of sound, so somewhere in the range of Mach 0.8 to 1.2. For reference, commercial jets have a range of cruising speeds, but most of them fly at speeds between Mach 0.74 and Mach 0.85, so that's 480 to 575 miles per hour or 770 to 930 kilometers per hour.
And after transonic comes subsonic. That just means you're slower than the speed of sound. We're still well in excess of that right now. But by the time we hit subsonic, we're essentially belly flopping down. There we go. There's that sunlight. So we're seeing the Earth now come back into view. One of the other things we're doing during this, and you're going to see Starship kind of pitch in some pretty, not extreme ways, but a little extreme, as we're trying to really stress the structure of the ship itself, specifically those aft flaps, so the ones in the very bottom of the vehicle. We're pushing not just how well does the heat shield hold up, but how well does the ship structure hold up. We are pushing it beyond essentially what we think we'll have to fly at to do something like a return to launch site. So again, may not be a very smooth ride downhill, but we're doing that by design. We're really trying to find what are the edges that we can operate at, build up a good data set. But sun is up, clouds and water down below us. We are just about 10 minutes away, a little less than 10 minutes now, until we start hitting transonic and then subsonic. Once we hit subsonic, we're basically just belly flopping. All right, so about 55.5 minutes in, you can see the sun is up. Again, we intentionally designed these flights to lift off in the evening here so we get these daylight views so we can get as good a video as possible on the ship, assuming we make it all the way down. We've got at least one buoy powered by Starlink that's out there in the landing zone in the Indian Ocean, hopefully giving us a view again. If you see any live views, not from the ship itself, that means we nailed our landing target.
Starship is past peak heating.
All right, we just heard the call out that we're past peak heating, so things are looking good so far.
Yeah, looking good. And at this point, again, the flaps are controlling, so this movement you're seeing is that forward flap moving to try and just maintain control, maintain attitude of the vehicle as we're coming down. Checking in on one of our flaps. We got one of these cameras on all 4 of the flaps, 2 in the front, 2 in the back, giving us really good close-up views. As we obviously don't have a camera that can see the entire heat shield. These give us kind of the best that we can do. But looking at those flaps is really, those are just, you know, super critical for controlling the ship. You have some ability to maneuver kind of cross range. So as you're coming in, you can see in that indicator at the very bottom right that we've pitched up quite a bit. So again, we are maximally stressing those aft flaps right now. Looks like we got a little bit of burn through the very bottom part of it. Everything's still looking good. Ship maintaining control. We should be just about 5 minutes away until we hear that we're transonic. Still a little bit toasty on the aft skirt of the vehicle as we continue coming in.
Again, we are intentionally stressing the flaps so we can learn all we can.
All right, so now we're already well past peak heating. Just about 48, 49, counting down to 48 kilometers in altitude. Expecting that transonic to come, so transitioning between the speed of sound and subsonic slower than the speed of sound in just a little under 4 minutes from now. And right now we've got kind of a lot of forward momentum, a lot of forward velocity, and then eventually by the time we hit subsonic. All right, here we go. So this is what we've been talking about, where we are going to essentially try to fully deploy those aft flaps and really stress them out. So again, this is meant to test the extremes for the vehicle. All right. See those flaps swinging out? Again, we're putting ship through the ringer on this flight in. It's like we're still maintaining control. All right, flaps earning their paycheck today, getting through kind of that max stressing.
Definitely things looking good so far. We're about 2 minutes out now from Starship becoming transonic.
One cool thing to note as we get some of those views showing kind of the whole length of the ship, one of the changes we made after Flight 6 was to change the tile line a little bit. So we had kind of scaled back the number of tiles significantly, as when we go to catch these ships, you don't want to, I think as Elon said, you don't want to shuck the ship as you catch it and knock all those tiles off. So we knew we were going to have to kind of peel back that layer a little bit. And the first time we did it was on Flight 6, and we saw kind of wrinkling and dimples almost in the ship as we were creating these hot spots in the uneven parts of the heat shield. And so we kind of address that. We smoothed it out. That's why you've got kind of that nice smoothed out black line now on the ship. And just looking at it, we can see kind of a little bit of hot spot, a little bit of warping almost. Near the payload door, you can see a little bit of colored patina up above it, but we don't see those kind of deep, almost, you know, they almost look like gouges on that. So it looks like that's been pretty successful. So, all right, we are less than a minute away from hitting transonic. Again, pretty soon our forward velocity is going to look like it's kind of falling off a cliff, and Starship will look like it's falling off a cliff as we essentially go into our belly flop. If you watched some of the high altitude tests or suborbital campaigns, we were able to test that. It was a pretty fundamental, like, can this thing actually fly? And we were able to prove that out with that suborbital campaign. And that's what we're about to see shortly here. All right, so at this point, we've dropped below the speed of sound, so Starship itself is subsonic. We are starting to chill the engines for a landing burn attempt. Landing flip supposed to start in a little over 2 minutes. Subsonic Indian Ocean, we're on our way.
Starship is subsonic.
There we go. Farewell, space. All right, so coming up in just a little under 2 minutes, so we're going to do the flip and the burn. So we're only using those 3 center Raptor engines, the sea levels, the ones that can kind of gimbal, that can move around and steer. Dipping the nose down a little bit. Got 2 of our engines chilled in, waiting on 1 more. So again, we'll attempt to use 3 burns for that initial flip. We eventually go down to just 2 Raptors for the end of the landing burn.
Just about 1 minute now from that landing flip and landing burn start.
Structurally, we're looking good. Got good pressures in our nose cone for everything. Just about 30 seconds. So again, we're going to look for the flip. So Starship's doing its belly flop right now. We're going to do the flip. Swing out. Let's punch through some clouds first. Here we go.
Starship landing burn startup.
Seeing 3 engines. There's our flip. There's a buoy.
Oh
There's a splashdown. Hey. Oh, man. Yeah, farewell, Ship 37. Thank you, buoy cam. Landing flip, landing burn, splash out of the Indian Ocean. There we go. Whew. All right. That was pretty awesome.
Incredible flight
cool, right?
today for both ship and booster.
Yeah, really incredible. So obviously we're excited here. It looks like everybody's excited over there. Tyler, how's it going over in Hawthorne?
We are super excited here in Hawthorne. It was another exciting Starship flight test in the books, and we hope you enjoyed those Starlink views. So congratulations to the team at Starbase and everyone here and around the company. So many employees have contributed enormously to the Starship program as we continue to iterate and make progress towards a multi-planetary future. So that's going to wrap it up for us here in Hawthorne. Thank you to everyone for tuning in today. It was great being with you today. Back to you guys.
That was absolutely incredible. Huge congrats to all the teams here. Again, we lifted off from Starbase, Texas, right at the top of our window at 6:30 p.m. Central Time. We saw Booster successfully lift us up through ascent, had a successful hot staging where ship continued on with its suborbital trajectory. Booster came back down, had that boost back burn, and a successful landing burn with that unique engine configuration as well.
Yeah, and then ship continued on its way, made it all the way into space. We got to see first ever payload deploy.
So exciting.
That was awesome. We got the door open, 8 Starlink simulators deployed, relit that Raptor engine, and then on entry we probably gave it a little bit of extra time in the oven, but made it all the way through re-entry. All 3 engines started up, landing flip, splashdown in the Indian Ocean. Promised maximum excitement, Starship delivered.
Most definitely.
Congratulations all of our teammates here at SpaceX. It's been a year. Everybody that's worked on this program, this is what we're working for. So big congrats to all of them. Thank you to all of our future customers, too, for your support.
And we'd also like to thank the fine people of Cameron County, including the residents of its newest city, Starbase, as well as the Coast Guard, the Federal Aviation Administration, the Government of Mexico, and the Australian Space Agency.
Be sure to stay tuned to SpaceX on X for updates, more of the views. This is just a tiny amount of the views. We have so many views that we didn't get to feature on the broadcast. So we're going to be going through that over the next couple of days, and we'll be posting it all there.
Yeah, if you're interested in more launch coverage, head on over to spacex.com/launches for the most up-to-date information. In fact, we actually recently rolled out a new departure board featuring our upcoming launches with details like mission name, launch and landing site, and liftoff time. So be sure to check it out.
All right. We just launched the world's biggest rocket. Again, dropped a couple satellites off, suborbital.
Incredible payload deploy for today.
Nailed that double header into the ocean, splashdown, time to go through the data. Really crazy cool to hit all those objectives today.
Yeah, huge shout out to all the teams who make this look easy. And thanks to all of you for tuning in, and we will see you back here for Flight 11. Good night.